Hello and welcome to this recorded session for our Developer Summit 2020. Our session is entitled ArcGIS Enterprise Data Storage Strategies. My name is Tom Shippey and I'm an instructor and a tech lead out of the Redlands office. I do curriculum development for our enterprise classes, and with me is Nana Day, who is a product manager on the data management team. So each of us gets kind of questions in different ways. So hopefully between the two of us we'll be able to kind of take this session and be able to deliver it to you. So first of all, we'll take a look at our agenda. So we want to start off, kind of cover three major areas. What is a data strategy and why do you need one? And then I'm going to come back and talk about ArcGIS Enterprise data, the landscape, and a little bit about architecture. And then Nana's going to come back and really kind of talk us through the process of developing that data strategy, kind of a block at a time, a piece at a time, kind of putting the items together. And I guess just one little note, full disclosure, on the agenda, this is probably called data management strategies, but we thought that it was a much bigger topic than that. And so we wanted to cover not just the management of data, but a lot of different aspects of being able to have your data strategy. So one of the things that happens to us all the time in our classes, and as I know Dana's interacting with customers, we get a lot of questions about the software. We get questions about, should I be going to some new technology? What should I be implementing? How should my workflows work? And all of that. And so those are a lot of questions that come to us, but are those the questions that you should be asking? So we want to look at some common questions and then sort of back them up a little bit and say, okay, what is it that you should be asking? So one of the common questions that we get all the time is, should I be moving all my data to the cloud? Nana, what do you think? What would you say to them, somebody who came with that question?
Well, Tom, it depends. With such a question, what are the needs of the business? As the demand for data and services growing at a rate where the architecture can keep up. There are several factors one needs to be able to consider in such a migration. One of them is accessibility. Let's just take, for example, we have migrated our data in the cloud in San Francisco. Where will the clients live? Should the clients be in Boston? We have ArcGIS Enterprise, we have ArcGIS Pro. Are we still keeping those in Boston? So that means that we need to be able to review our needs to determine how best the needs can be met. And in such a case, latency is a big one. So we will need to be able to locate our ArcGIS Enterprise as close as possible to where the data is. And then all the various clients, ArcGIS Pro and mobile devices, can get to consume services. So Tom, it depends.
Yeah, so it sounds like there's a lot of considerations, not just software and technology. Here's another one we commonly get. Should I convert all my shapefiles?
Oh, Tom, I love shapefiles.
Me too.
But at the end of the day, shapefiles, it all depends on the various workflows that we have been using them for. What are the needs? When we use shapefiles, do we use them primarily for archiving purposes? Do we use that primarily for data exchange? If that's the case, they still work and they're still supported. In addition to that, one can actually get a review how they can get to use geo packages to be able to support it. If there are newer use cases that demand, let's just say, the use of topology to be able to look at topological relationships between feature classes, then we may get to think about moving over to using a geodatabase instead of shapefiles. So Tom, it depends.
It always depends. Here's another one. Is the ArcGIS data store replacing my enterprise geodatabases? I can actually answer this one. We get this all the time in our classes, and the answer is just a resounding no. ArcGIS data store is a way to implement some WebGIS capabilities, but it works hand in hand. It complements enterprise geodatabases to really give you a full range of data options. So I'm going to turn it over to Nana and let you kind of talk through some of those questions we should be asking.
Okay. So Tom, since the choices we make really depend on the need, we must always start from asking ourselves the why. Why are we doing what we're doing? At times we start by reviewing what tools we can get to use to perform a task. But when we take a step back, we have a better understanding of how we can get to review the various components we need to be able to put together to accomplish a goal. So we should always get to start from the why. What is the need? Which specific problem are we trying to solve here? And then review the audience that we are serving. A CTO may look at results in one way, and a GIS analyst may look at the same results in a different way. So right from the get-go, we need to sit down and review why we're doing what we're doing. We need to review the need and review the audience. And then we move into the how stage. The how stage is where all the data management activities happen. How will the business needs be represented in the data? Data is really the foundation of every business, and we need data to make well-informed and better decisions. And as you know, our analysis is as good as the data we use. So it's extremely important to be able to state how we're going to manage the data to be able to satisfy the goal. So how are we going to collect the data? Are we going to be collecting the data in the field, or are we going to be ingesting the data from sensors? How are the data going to be stored? Are they going to be stored as vectors in our own data store, or as rasters in an ArcGIS data store? How are we going to maintain the data? Essentially, will there be quality control on the data? How are we going to set up attribute rules to be able to ensure that we have good data integrity? How are we going to model the data? There are various use cases that demand specific kind of data models. If we're looking at trying to be able to work with the transportation network, we may need to think about working with a network data set. Or managing utilities, we may need to think about the utility network. And how are we going to share the data? Is it going to be just internal, or are we going to share the data with the community? So in such a case, we need to be able to review how best we can get to curate the data so that the community can get to see some aspects of it, maybe not all of it. And then from that stage, we get to move into the what resources that we're going to use to be able to support all the various activities that we're going to do at the how. So with the why and the how, we move into what applications, what tools, the data, the documentation, and the engineers who would actually help to be able to put this whole architecture together. So the why provides a direction to how it can be achieved and what resources we can use to be able to achieve it. So it's really important. It's a really important step in this this whole setup in building a comprehensive data strategy. So,
wow.
So when we start with the why, we lay a very strong foundation to building such a framework.
That's awesome. And I think probably what we see, and I'm guilty of this myself, is people starting on the what end and going backwards and trying to build to their customers. So that's good to know.
Yes. So essentially a comprehensive data strategy is a well thought out plan, a vision for how an organization will get to store, collect, access, manage, analyze, and share GIS data. So it's a living, breathing document that all these aspects must be laid out in a way that everyone can get to review it at any point in time. So a data strategy must definitely be feasible. We should be able to put it together in a way that we can get to attain it. Why put something together that can be achieved? So we need to ensure that all the aspects that we put in together is actionable. And it must integrate with other systems. There are scenarios where we need to be able to integrate other systems with the GIS to answer specific questions. And all these must be tailored to the various workflows that the users are using. And it evolves. 20 years ago, we may have been using shapefiles to meet a certain need. Today, we may need to be able to think about something else to be able to satisfy the same need, or maybe there's a new demand for it, so that strategy needs to evolve. So, Tom, bear with me for a second.
I'm hungry.
Bear with me for a second, Tom. But I just want to use this as an analogy because when you look at all these dishes laid out, at times it can be a little bit daunting trying to figure out how best I can get to come up with a data strategy. So let's just say that we have all these dishes that a restaurant needs to be able to make. And it can be a little bit difficult trying to think about how can I put all this together. But if I go ahead and start with one dish, let's just review how I can get to satisfy one dish. And then we can get to work our way through all the various dishes. And as we said earlier, it's always important to be able to start with a why. So let's start with the end goal. What are we trying to achieve? We're trying to create a dish for a buffet for persons with no allergies. And that must be defined at that stage, because if we were creating a dish for persons with some allergies, the ingredients and certain aspects of the things that we're going to put together may change. And that's why it's important to be able to start from the end goal and then work our way back into all the pieces that we need to be able to put together to create the dish. So I'll hand it over to Tom for Tom to take us through the ArcGIS data landscape and architecture. And I'll come back again to see how best we'll be able to put the building blocks together.
Awesome, thanks, Nana. I think that when you actually come back and we see some of the things that you have as concrete recommendations, I think people are going to really appreciate it.
Yeah.
But we want to start and try and kind of understand a little bit of what's available out there. And when you go to a conference like this or you're any place, you're going to be kind of overwhelmed by all of the different possibilities that are there. So I want to back up a little bit and look at things from a historical perspective and then talk a little bit about architecture. So historically, we could think of GIS as starting out in a desktop application, and there we would use file-based data. We could have that data. The only way we could really share that data with other people would be other desktop users that are there. But that really sort of isolated us, and the need to be able to have multiple people working on data sets was really important, and that's where the multi-user geodatabase, ArcSDE, came in. That allowed multiple people to be working on the same data. It rested on top of real enterprise databases, and that gave us then a way to collaborate and have data that was there. But again, it was really the GIS community. We were able to work with our own peers. We wanted to open that up, and that's where ArcGIS Server came into play. It took that data and now was able to represent it through kind of this new technology called a web service. So you could get to data through URLs, and there was the development of various kinds of services, and in particular the feature service that allowed us to even be able to edit that data that was there. So we now had data we could work with in our organization, data we could share externally, but it was data that was hard to get to. And so when ArcGIS Online came around, it offered a new way of being able to access and use data in a real user-friendly way. It opened up what we call a system of engagement for people to be able to contact and work within a kind of a portal environment that was there. That then made that data so widely available, we needed to figure out a way to scale. So scaling the feature services was probably the biggest data enhancement that came with the ArcGIS, or the ArcGIS Online, which really allowed us to do this idea of WebGIS. And of course, that concept caught on to such an extent that the folks behind the firewall wanted the same thing. And ArcGIS Enterprise sort of pulled all those pieces back together for the users that were there. But Enterprise then went ahead and took and extended capabilities through a process we call federation, and that then allowed new types of data to be addressed, created, and accessed. So it's been a good history. Let's take a couple of minutes and look architecturally at how Enterprise goes together. So we can think of Server as being the heart. It's the engine that provides those web services. Portal as being the front end. It's providing us with the ability for our users to have the data and work with it and upload and have all kinds of various pieces of information. But we also need a place to store data right out of the box, and that's what the ArcGIS Data Store provides. So these three components working together really comprise what we would call a WebGIS. That's the ability for us to have things like analysis and working with different kinds of files that are there. But that's not really the complete story for, I would say, almost 100% of our users. Most people also have their own data from those enterprise geodatabases, from folders, and even from some new kinds of ways of working with it through cloud storage. So then we really have this basic architecture of data that users provide and then data that gets created as part of the process of enterprise. So let's look at a couple of kind of use case patterns. I think probably one of the would be most recognized to people who are from a GIS background would be this referencing your data. So you might be on a desktop application like ArcGIS Pro. You would connect to ArcGIS server. You'd connect in with a set of user credentials. If you're in Pro, you just go ahead and sign into the portal directly, and then you can pick the server that you want to work with. You go ahead and publish that content as referenced or registered data. That's going to create an item in the portal for you. We call that a layer, feature layer, perhaps could be the kind. There's actually then a service that gets created out in ArcGIS Server, but the data always remains right where you left it, and you have complete control over it. Another common pattern is what we call self-service mapping. So here, users are connecting directly to the portal, probably through the portal viewer applications, and they may be doing things like uploading CSV files or shape files, and as they are interacting with the portal and bringing in those resources, then again, a layer item will get created, a service gets created in the hosting server in this case, and the data will be copied into ArcGIS Data Store. So that's the case where we don't need to have any external data available, but it provides a way for users to be able to use and access the system. I want to look at another pattern that's out there, and this is the enterprise analysis pattern. And it really starts off very much with that same self-service mapping, only we're looking at it just a little bit different. For standard analysis, we're taking our GIS hosting server and we're really working with that server that's there. We want to be able to host the results from the analysis that runs. And the data ends up being stored as the hosted feature classes in our relational ArcGIS data store. Now that's a great pattern that's been around for a long time, but in enterprise we can extend that even further to support distributed feature analysis. And here we're using GeoAnalytics server, multiple servers together in a given site, and accessing spatiotemporal big data store for our results, to output our results. So again, we've got the ability to do parallel processing and parallel writing. And it's again a different data location, but it's still data that we're familiar with. And then finally, we can do distributed raster analytics. And this then uses image server, and the data goes into what we call a raster store. And that may be a local folder, or it may be a cloud-based connection. So what I'd like to do is take these three models from this pattern and actually do just a real quick demo, kind of show you how this is implemented in our software. So here we have, I have gone ahead and taken a tree inventory from the city of Naperville, pulled it in, and basically I ran an analysis to go ahead and have these tree point features pulled into a spatiotemporal big data store. So it's a big data set that's here, but it's taking data from that spatiotemporal big data store. And then I said, well, I want to run an analysis on this. So I ran just a basic standard analysis to do hot and cold spots to see, okay, where might we want to plant more trees? Where do we have a lot of trees already? And then just to kind of do a little bit of analysis of how things would interact with the environment, I ran a raster analysis to go ahead and create a set of slope diagrams here to kind of see how sloping might work with the items. But all this is really just to show that I can have these three different data types. They're all represented in my map as just layers that are there. Let me go ahead here and show you what that would look like in our content. So here, I'm going to zoom in a little bit and take a look at Well, no, I'm not going to zoom in. Anyway, we have these three different layer types that are here. And what's key is that these icons are telling us a little bit about where the data is. So our local raster analysis layer here is going to an imagery hosted layer. Our analysis relational is going to a feature layer, and we have our standard feature icon. And then our spatiotemporal big data store layer has that ring icon from the spatial temporal big data store. So we're kind of trying to carry those across through the entire part of the portal that's there. Now, once these exist and there's a map that's available, then these can be shared basically anywhere we want. So I can go into my portal here and be able to go in and pull this map up, even in ArcGIS Pro. So I can publish from ArcGIS Pro, but I can also use ArcGIS Pro as a client application. And it'll pull up that analysis, and I can be able to look at it and share it pretty much across the platform when I want to. So that's pretty cool. But let's take just a little bit deeper look. That's the way users would interact with the data. But as a data manager, you might want to look at it a little bit more deeply than that. So if we come over and go to our ArcGIS Server Manager on our hosting server, we go to the hosted folder here, we'll actually see that there are three different services. There's an image service, there's a feature service that's accessing our relational database, and then there's a spatiotemporal big data store that is there as well. And so those data items are then part of ArcGIS Server. And I'll show you one more thing. We won't go too deep into this, but when you go ahead and specify your enterprise portal to do, say, raster analysis, then there's also some supporting system kinds of geoprocessing tasks that get turned on and are available then to be able to cause that analysis to happen. And so we can create a file like that, the file that's being used for our slope files. And what that would do is out on disk, it would create this hosted analysis and our local shared files. And these are then specially structured with various different scale levels, you could think of them as almost pyramids for a raster, that then allows for multiple different clients or multiple different tasks to be working at the same time in parallel. So this is where the data is supporting and growing and being a part of what's happening with the software that's underneath the covers. And then we see it here through a file system view, and we see it as folders. But when we go back into ArcGIS Pro, we can actually look at it and see it through our project here if we branch out to those folders. And that exact same folder is now represented here as a raster. And I can do things like look at the properties of that raster, and I can see that based on how that result got created, what kinds of data needed to be there, what its bit depth is, what its type, and all of that is kind of basically a way for us to be able to work with that. And so I could pull this in and actually be able to look at that, being able to put the pieces into place. So that's just kind of a quick look at some of the things that you might do with some of these new data types. So we basically saw that you could have features, you could have distributed and distributed feature, and you could have distributed analysis. So that's pretty amazing. And I think a big part of this, kind of a follow-up to this, is what are some of the data types that are available today? And so we've kind of tried to break this down into kind of what the storage type would be, what's the supporting infrastructure, what are some typical use cases, and what are some common formats. So we have file folders. Those are, I think, pretty familiar to everybody. They're going to be operating system files and folders, often on a network share. Typical use cases are going to be local data in our desktop applications, registered data that we share, and some project packages. And so all these are some of those formats we were talking about: shape files, text files, CSV files, rasters, etc. We also have our enterprise geodatabases. Now these live in full RDBMS environments. They often are managed by an IT or a DBA, but they have the ability to scale out to very large scales. These are supporting things like multi-user editing, or versioning, topology, attribute rules, and again, we can register this data as well and have some specialty types of data to support things like a utility network or parcel management. So again, we've got feature classes, we've got mosaic data sets, we've got parcel fabrics, we have utility networks, all kinds of different types of data that can live inside of those enterprise geodatabases. And then we can talk about our ArcGIS data store. So this is our kind of out-of-the-box data tier. It's an ArcGIS enterprise component. It supports 3 different types. We'll look at that in just a second. And these are often on their own dedicated hosts. So depending on how much data and how much access you've got, that'll be there. So it comes in these 3 different flavors. Relational, we looked at that. Tile cache is for 3D scenes. And then spatiotemporal big data is real-time and large data sets. So we might see things there like Tracker or the GeoEvent processor. And all of these, since they're managed within ArcGIS, are accessed as layer items in your enterprise portal. You don't have to know what that internal data format is, and ArcGIS is basically going to manage that for you. Then as we start to move up a little bit, we could say, well, we've got different kinds of cloud storage that are available. So we can have our cloud infrastructure, something in Amazon or Azure. We call that infrastructure as a service. You're going to manage those. You're basically renting space to have servers that are there. We have database as a service. So this is kind of new. We're seeing things like Azure SQL. Other providers are moving into this space as well, so that you can basically rent space in a database. And then we've got Amazon PostgreSQL RDS, and that's another example of different ways in which the providers are beginning to expand out. So our typical use cases here are certainly going to be large-scale imagery, raster stores, for our large map caches and image caches, maybe even as an ArcGIS data store backup location. So, you know, we could see sort of an interaction between some of these components. And we've got standard file formats, feature classes, query layers, which is an important one, cloud raster format, which is what we were just looking at in the demo, and then cache raster format, which is very similar. It's another kind of format for being able to have parallel data structures that are there. And then finally, big data is sort of emerging. Everything is data-driven these days. So we see at least right now, we're supporting Hadoop and Hive, and we use that as input to things like our big data geoanalytics that are there. But here we can support some of our traditional formats, shapefiles and text delimited. We've got ORC, that is optimized row column formats, and Parquet. So this is another area that's probably going to grow over time as we work with all these different kinds of data that are there. So I guess the question then, sometimes when we think about all of this data is there a way to maybe simplify a little bit how we think about it? And I think we might think about it in terms of how that data is managed. So who's in charge of it? And so kind of in line with what Nana's been talking about for food, we can think of user managed as being something, we've got the kitchen, right? We are going to create and work with and have that data. So in that case, it's going to be data that we're providing to ArcGIS. We're going to manage that data storage ourselves. You are going to provide the tools, you're going to provision, your scale, you're going to tune, you're going to even be in charge of deleting and updating the database. But you can make it accessible to ArcGIS Enterprise by registering it. And then again, we can publish through a server connection via ArcGIS Pro, which is what we saw in that first kind of model for the architecture. Now the other kind of data is ArcGIS managed, and we might think of this as kind of a real restaurant, an industrial place, or a large hotel where the data is being managed by the system. So this is data that is created and managed through ArcGIS. So ArcGIS Data Store instances or enterprise managed folders, like we saw where that raster data was stored. It's installed and it's configured as software. We set that up and we work with our administrators, but it's something that we keep in charge, or we work with. And it's managed via application user interfaces and SDKs. So we have the ability to affect that what's there. We can change where the locations of things are, but we don't go and actually do the hands-on of the data itself. So thinking about how that's managed is pretty important. And there's a really great white paper, Data in ArcGIS. It's user managed and ArcGIS managed. Pretty detailed discussion. It'll go through a lot of what we've talked about historically. But I think the real key takeaway here is this table at the end that gives us a comparison of functionality between, say, a user-managed example, which would be an ArcGIS Enterprise database, and ArcGIS managed in the ArcGIS featured data store. So this is worth going to and just being able to get a feel for, okay, well, how do these two complement each other and how do they work together? So data management is an important topic and one that you should be thinking about as part of your data strategy. But now I think it's time for us to think a little bit about how the environments can work together. So we have a public and a private WebGIS. We talked about ArcGIS Online. That's where you host data, and it's always going to be copied. It's got public content, it's open data, it's lots of places where we could have folks who may not be part of our organization and interact with them. And the neat thing about online, and just in the last month or two, we've had some huge increases in functionality. So Tracker for ArcGIS is now available through online, and some real-time capability. Analytics for IoT is also there. So there's a lot that you can do with ArcGIS Online. But ArcGIS Enterprise then takes and allows us to have a lot of that same functionality in our own environment where we're in control. So there we can have registered data, we can have those enterprise databases, we can have continuous and multi-user data sets, we can do all kinds of work with imagery, and we've got all that hosted data that is there as well. So we're going to support self-service mapping for our users, and we can do those analysis. All of those analysis functions that I did were on Enterprise, my Enterprise system. And of course we can deploy it either on site or in the cloud. But the real, I think, value of this is that now these guys work together. They are able to collaborate with each other and share data directly. And there's different ways, too, that you can connect Enterprise and Portal. But this collaboration allows you to be able to basically replicate data across these portals now. So you can have people working back and forth together. So there's a lot that you can do in the landscape that's available through ArcGIS. I'm going to pass it back to Nana, and we'll talk a little bit about data strategy building blocks.
Thank you, Tom. Thank you, Tom, for taking us through the ArcGIS Enterprise data landscape and the various options that we have. So we started off with trying to create a dish here. How can we get to use this analogy to build a data strategy? So here, let's look at the building blocks that we can get to put together to be able to create a data strategy. The concept of creating a data strategy is the same irrespective of the industry or organization. And here we're just using the dish as an example to see how we can get to break things down. So we started off with the why. It's very important to be able to start with why we're doing what we're doing. So we need to define the need. And here the need that we define will dictate what happens in the how and then in what stages. So at this stage, we are simply defining the problem. So we won't be bringing the solution over into the problem definition stage. And we need to review the audience. Going back to making the dish, we needed to create the food for persons with no allergies. So the audience has been set. So here, the real why is feeding hungry. And then we dive into how are we going to put it together? This is where the data management aspects come in. How is the data model going to represent the need? How is the data going to be collected, stored, analyzed, visualized, and shared? So this is a stage where we get to put all the ingredients together to be able to satisfy the why. Then we move into the what stage to define the various resources that we would need to satisfy the how and the why. So here we come up with the data types that will be supporting the workflows, the data stores that will support them, which applications we're going to use, and how will the IT administrators or the data architects help us be able to put everything together to ensure that the why is met. So in comparing that with the dish, we'll be looking at using the kitchen, the various tools, the recipes, the chefs, and the buses all together to be able to satisfy we feeding the hungry. So when we get to put it all together, we would have a very simple form of the why, how, what. Why, essentially the need, the audience who we're serving. The how is where all the data management workflows and activities can get to live. And then the what will be the resources that we will use to be able to put everything together. So if we look at an example that we have a city who needs to be able to maintain an accurate inventory of their parcels. And the audience was the GIS manager and the data manager. The GIS manager and the data manager needed a view of how the parcels are being maintained over a period of time. So in the how stage, how is this going to be done? Editors will be performing topological edits against feature services in the office. Some would also be going over onto the field to perform offline edits, and then when you get back into the office, it will sync back to the feature service. And then administrators will go in to perform quality control activities on the edits that have been made. And also, at times we set up data integrity options so in a way that it will make the QA process easier. And the management needs a dashboard to be able to report all the parcels that have been updated over the last certain number of days. So in this simple example, the why and how dictates the what resources that we will need. So if we would need to be able to use a feature service and perform topological edits, then one will start thinking about using an enterprise view database and an ArcGIS Enterprise. We will be using ArcGIS Pro to be able to make the edits, and then the field editors, we're going to use Collector for ArcGIS as a mechanism to make the field edits. And then putting everything all together with using operations dashboard for ArcGIS so that the managers can get to have a view of the parcels that have been updated over a certain period of time. So even though that this is a great way to be able to start coming up with a data strategy, this is not a de facto standard. There are certain organizations who will come up with this architecture in a workflow diagram, like a workflow chart. But irrespective of what the end goal is, we need to, this is a starting point of how you can get to combine various tools to come up with a data strategy. So I hope that you will be able to use this as a starting point going forward to be able to review data strategies, because it's a living, breathing document that will change over time.
Man, I love this forum. I'm going to steal it, if you don't mind, for classes and take it to my students, because I think it's a basic, simple enough structure that anybody could fill that in. And then I love your example here too. All right, that's great. So I guess we've got a couple of related sessions that you might want to catch the recordings and the slides for. Just go back to and check for anything that has ArcGIS Enterprise and data in it. You might find some additional things that are there. But definitely ArcGIS Enterprise publishing content and services would be a good one. And ArcGIS Enterprise best practices for layers and services. I love that session too. So. Yeah. I think with that, we're going to wrap it up and say thank you so much for listening. And we hope that this has been useful to you and that you can create your own data strategies back home. You have anything to wrap up with there, Nana?
I think you summed it up well, Tom. You summed it up well.
All right. Thank you. And we'll sign off for now.
Thank you.